In this lecture, we'll see short method of finding particular integral whenever qx is of the form cos ax plus b or sin ax plus b. We'll cover these topics. We'll see the method. We'll see 3 examples in this lecture. So consider the general nth order linear differential equation of the form f dy is equal to qx, where fd is having this form, where d represents derivative with respect to x, that is d by dx, where the coefficients a0, a1, an are, these are the constant. For certain particular forms of the non-homogeneous term qx, that is this one, in the above equation, there exists shorter method of finding particular integral. We'll see one of the form of qx and we'll find the shorter method. So the question is, explain the method of finding particular integral when q is of the form cos ax plus b or sin ax plus b. So for the solution, we know in successive differentiation of cos ax plus b gives, when we find the first derivative of cos ax plus b, we get minus a sin ax plus b. When we find the second derivative of cos ax plus b, that is the derivative of this one, we get minus a square cos ax plus b. Similarly, when we find the third derivative of cos x plus b, that is the derivative of this with respect to x, we get a cube sin ax plus b, that is because the derivative of cos x is minus sin x. Similarly, when we find the fourth derivative of cos x plus b, we get a to the power 4 cos x plus b, derivative of this, that is, and this can be written as minus a square cos x plus b. Therefore, following this way, in general, we can write that d square to the power n cos x plus b can be written as minus a square to the power n cos x plus b. Thus, if phi d square is a rational integral function of d square, then simply we have phi d square cos ax plus b is equal to phi minus a square cos x plus b, and phi d square sin ax plus b, same way with the sign, phi minus a square sin ax plus b. That is what we have to do. We have to simply replace this d square with the minus of a square in this case. Now two cases arise. If case 1, phi of minus a square is not equal to 0. In this case, what happens? When we operate phi d square on this expression cos ax plus b upon phi minus a square, then we get minus 1 upon phi minus a square. That is, this expression comes out, and phi d square when we'll operate on this, and we have seen in the previous slide, this becomes nothing but d square is replaced with minus a square. So this becomes 1 upon phi minus a square into phi minus a square cos x plus b. And this 2 will get cancelled and cos x plus b. It implies similarly, this is same way with we can see with the sign. The sign also will get this. So this implies this cos ax plus b upon phi minus a square, this is the particular integral in case of cos, and in case of sine, this is the particular integral whenever phi minus a square is not equal to 0. So 1 upon phi minus a square cos ax plus b is a particular integral of phi d square y cos ax plus b, and 1 upon phi minus a square sin ax plus b is a particular integral of phi d square y sin ax plus b. So same way with cos and sin, we'll get the same result whenever phi minus a square is not equal to 0. That is, we have for phi minus a square is not equal to 0, simply whenever we have to evaluate this, simply d square is replaced with minus a square. Here this d square is replaced with minus a square and we get the particular integral. Now case number 2, if phi minus a square is equal to 0. If this is the case, then phi d square will be of this form: d square plus a square to the power some power, say p, into xi d square, where xi minus a square is not equal to 0. This types of expression we will get. So in this case, we'll write 1 upon phi d square cos x plus b, and this will become this expression cos x plus b. Now here phi a square will write first, and we'll start with this expression. This will write second, because this phi a square will come out using the formula that d square is replaced with minus a square, so it will come out, and this can be evaluated by general method. What is general method? We'll see in the examples. Similarly, in case of sine, this expression will become 1 upon psi minus a square will out, 1 upon d square plus a square to the power p into sine ax plus b. Again, the general method we'll see in the example. So let us see one example. Find a particular integral of this expression. So because we are interested in particular integral only, so we will start with yp. So this expression is written over here, 1 upon fd cos 2x plus 3. Now this d to the power 4 can be written as d square into d square tan d square plus 9 cos 2x plus b. Here the value of a, you can see, the value is 2. So d square is replaced by minus 2 square. Here also minus 2 square, tan into minus 2 square plus 9. Simply we are going to put these values, because here in this case, this your phi d, phi minus 2 is not equal to 0. So we can put the values over here directly, and we are getting this result. And we'll simplify this. We get minus 1 upon 15 cos 2x plus 3. So this is the answer in this case. Now let us see the second example. Here, find particular integral of d to the power 4 minus 1 y is equal to sine x. We'll write 1 upon d to the power 4 minus 1 sine x. We divide it into this two expression, d square minus 1, d square plus 1, using the formula, because this d to the power 4 minus 1 can be written as d square square minus 1, and using the formula we can write this expression from this. Now here simply, because here there is no problem, we can put the minus 1, a is equal to 1 here. So this d square is replaced with minus 1 square, that is minus 1. This minus 1 comes here over here, d square plus 1. So we get this expression. Now here, this 1 upon d square plus 1 will use the partial fraction, and this can be written as this way. So this is minus 1 by 2, 1 upon 2i, 1 upon d minus i, 1 upon d plus i sine x. So this expression, when we'll multiply this 2, we'll get this. These two are separated, and from this, now you can see the use of general method of finding this. This is 1 upon d minus i sine x. So this is evaluated as a e to the power ix integration sine e to the power minus ix sine dx. In general, if you are having d minus a and some expression, so this expression will become e to the power ax integration e to the power minus ax, that expression, into dx. So using this, we have written this over here. So e to the power ix, e to the power minus ix sine ax. Here it is d plus I, so it can be first written as d plus minus 1. So here, first we write minus e to the power minus ix, then minus of minus, so e to the power ix sine x dx. And simply this expression will become this expression, and sine x will write in this way, because sine x can be written as e to the power ix minus e to the power minus ix divided by 2i. So using this formula, we have written the change the value of sin x in this exponential form, and simply when we'll multiply inside and we find the integration, that is very easy for you. So when we'll find this integration over here, so this will evaluate it, integration, and we'll get this value, these two values. When we'll simplify this further, this can be written in this form. Here, this becomes e to the power ix plus e to the power minus ix by 2. This becomes the formula for cos x. So this is cos x, and here it is multiplied by 2. And this simply becomes the sin x. So this is our particular integral in this case. And we have used these two formulas which we have already used in the question. Now one more question we'll see. Here d cube plus d square minus d minus 1 y is equal to cos 2x, that we have to solve. So this is auxiliary equation, and from this is the complementary function that you can do, that you can find very easily. Now we'll go to the particular integral. This can be written as 1 upon d cube plus d square minus d minus 1. And we factor this, we get this expression. Now here, note that we have multiplied the whole expression with d minus 1 and d minus 1 in numerator and denominator. Why this is so? Because in the numerator it becomes d minus 1, and this 2 together again becomes d square minus 1. So d square minus 1 and d square minus 1, this becomes d square minus 1 to the power 2, and d minus 1 is in the numerator. Now d minus 1 is as it is, and d square is replaced with minus 2 square. So this expression will become minus 2 square minus 1. So this is and it's a square, so it becomes minus 5 square in the denominator, so it becomes 1 upon 25 cos 2x. So this comes out 1 upon 25 d minus 1 cos 2x. Now this is operated on cos 2x, so we get minus 2 sin x minus cos x, and this is the final value of your particular integral. So by this way, these types of question can be solved as the complete solution is, this is the complementary function, this is the particular integral, this is complementary function, this particular integral, and you can try these questions. These are very easy. By following these methods, you can solve this. Now we'll see the another method of solving this. Whenever bx is equal to cos ax plus b or sin x plus b, this is the one of the method. This also you can try. In this case, what we'll do, we'll convert the sin ax by, suppose we want to solve this, we have to find this value. But in place of this, we will solve 1 upon d square plus a square e to the power iax. And when we'll solve this, so we'll convert the sin ax into the exponential function. We'll find the, using partial fractions, we'll find the factor of this, and this can be written in this way. Now e to the power ix goes inside, that is, these are operated on this. And here, because here d is equal to ai, if I put, then it will become 0. So this will make problem, but here it does not make any problem. Here we will simply put the, in place of d, we will put ai, and here we'll use the general method. What will be general method in this case? That is, we'll multiply with e to the power iax integration e to the power minus ix into e to the power ix. So this second expression as it is, and this simply when we'll solve, we'll get this expression. So this u, when we'll write the value of, again, the e to the power ix is cos ax plus I sin ax, and e to the power iax, from this also we'll write this expression, And now from this is a complex number, and here when we find the imaginary value of u, we'll get the value of v, that is the value of this. Similarly, when we'll find the real value of u, we'll get this expression. Whenever cos is required, we'll find the real value of u. So whenever the value question of sine or cos comes, in place of solving directly, we can convert into exponential form and we can solve also. Thank you.